Hello, my dear children. Welcome to the mathematics class. Today, we are going to discuss limits and derivatives. Limits and derivatives. In this chapter, I have already explained some questions in the exercise 13.1 till the question number 25. I have already explained in the previous classes. Okay, my children. Right. On request of some students, I am explaining some more questions in this exercise 13.1. Okay, my children, are you ready to listen the class? Right. See the question number 27. I have already explained question number 25 so far. See the question number 26, same as that of question number 25. In the question number 25, modulus of x is given in the numerator, but in the 26th question, modulus of x is given in the denominator. But we have to convert the given function. As we have changed the given function by using the modulus function definition. Okay, my children. So, will you try the question number 26 yourself, my children? Same as that of question number 25. Try question number 26 yourself, my children. Okay, my children? Right. Now, come to the question number 27. Find, as x tends to 5, limit of f of x, where f of x is equal to mod x minus 5. Okay, my children? Understood this question? We have to find the limit of this function f of x as x is approaching to 5. Okay, my children? Right. Here f of x is defined in the modulus of x, absolute value function. So, you have to recall that definition of absolute value function. What is absolute value function? We know that modulus of x is equal to x if x is greater than 0. Modulus of x is equal to minus x if x is less than 0. Do you remember this absolute function definition, my children? Modulus of x value is equal to x if x is greater than 0, and modulus of x is equal to minus x if x is less than 0. Now come to the question. For which value x is approaching 5? X is approaching to 5. Is it greater than 0 or less than 0, my children? Yes, it is 5 is greater than 0. Isn't it or not, my children? Here, x is approaching to 5. Okay, my children? Then mod x is equal to x only, because 5 is greater than 0. This number is greater than 0. Okay, my children? Right. Now let us rewrite the given function. Therefore, f of x is equal to, in the place of mod x, we should write x only. Understood this step, my children? X minus 5 only. We are rewriting the given function with the help of absolute value function, as we have written in the question number 25. So here also we are rewriting the given function. Understood this step, my children? Right. Now let us find the limit. As x tends to 5, limit of f of x is equal to, as x tends to 5, limit of, now what is f of x? X minus 5 only, not modulus of x minus 5. Okay, my children, understood this point? Right. Now use the substitution method. Okay, my children? Then in the place of x, we substitute x is equal to 5, because x is approaching to 5. So we substitute x is equal to 5. So 5 minus 5, that is equal to 0. Therefore, as x tends to 5, limit of f of x is equal to 0. Okay, my children, understood? Right. Now come to the question number 28. Next question, my dear children. Suppose f of x is equal to a plus bx, comma x less than 1. F of x is equal to 4 when x is equal to 1. F of x is equal to b minus ax when x is greater than 1. Understood this function, my children? F is defined in three ways in different intervals, and as x tends to 1, limit of f of x is equal to f of 1, and this is also given for us. What are the possible values of a and b? Then we had to find the values of a and b, possible values of a and b. Understood this question, my children? Right. Come to the solution part. Let us write the given function. Given f of x is equal to a plus bx when x is less than 1. F of x is equal to 4 when x is equal to 1. F of x is equal to b minus ax when x is greater than 1. I wrote here the given function. Here the function is defined in three ways. Isn't it or not, my children? In three ways. In different intervals. X less than 1, this is one interval. X greater than 1, that is another interval. Okay, my children, x less than 1 means minus infinity comma 1. Isn't it or not, my children? Minus infinity comma 1. If you want to write this inequation in the form of interval, this can be written as open interval minus infinity comma 1. Similarly, this is the second interval, 1 comma infinity. 1 comma. Do you remember this point, my children? How to write an inequality in the form of interval? In the inequalities chapter, you have learnt that point. If you want to write x less than 1 in the form of interval, we can write it open interval minus infinity comma 1. X greater than 1, this inequality can be written as in the form of interval as open interval 1 comma infinity. Okay, my children. In this interval, f of x is defined like this. In this interval, f of x is defined like this. Exactly at x is equal to 1, f of x is defined like this. Understood this function, my children? Right. And what is given? And given that x tends to 1, as x tends to 1, limit of f of x is equal to f of 1. As x tends to 1, limit of f of x is equal to f of 1. This is also given for us in the question itself. Okay, my children. So, here as x tends to 1, limit of f of x means left hand limit at x is equal to 1 and right hand limit at x is equal to 1. Both should be equal. Okay, my children. For the previous questions we have discussed at that point. If left hand limit and right hand limits both are equal, then the function is said to be having the limit exist. Otherwise, if they are not equal, the function is said to be does not have the limit. Okay, but it does not exist the limit. So here as x tends to 1, limit of f of x means here as x tends to 1 minus limit of f of x is equal to as x tends to 1 plus limit of f of x is equal to f of 1. Understood this point, my children? This symbol stands for left hand limit and right hand limit both exist, both are a finite real number, and moreover they are equal. Then only we say that the function have limit exist. Otherwise, if they are not equal, we say that limit does not exist for that function as extends to that particular point. Okay, my children, understood this step? We wrote is equal to f of 1. So this can be written as x tends to 1 minus means left hand limit at x is equal to 1 is equal to as x tends to 1 plus limit of f of x means right hand limit. Both are equal. Okay, my children, understood this point? We use this knowledge. We use this concept to find the values of a and b. Okay, my children. First of all, I will represent this function on the number line. graphically. See here. Let us consider this is the number line. At which point the function is defined at 1, isn't it, my dear children, or not? Less than 1 and greater than 1. So exactly at x is equal to 1, f of x is equal to given as a 4. Okay, my children. Then left side means x less than 1. F of x is defined as f of x is equal to a plus bx. Understood this function, my children? Left side, left hand limit. We find here left hand limit. With the help of this function, we find the left hand limit. Come to the right hand limit, right side, x greater than 1. How the function is defined? F of x is equal to b minus ax. So when you are finding left hand limit of this function f of x at x is equal to 1, we have to consider this function only. When you are finding the limit, right hand limit of f of x at x is equal to 1, we have to consider this function only. Understood this point, my dear children? Right. Let's consider this equation is 1 because after finding the left hand limit of f of x at x is equal to 1 and right hand limit of f of x at x is equal to 1. After finding these two limits, we substitute in this equation and we solve them. Okay, my dear children? Understood? Right. Now come to this part, my dear children. We are finding left hand limit and right hand limit of f of x as x is approaching to 1. Okay, my dear children? How do you write symbolically left hand limit of f of x as x tends to 1 minus limit of f of x? Do you remember this symbol, my dear children? Do you remember this notation? Left hand limit of f of x as x is approaching to 1. Not? Okay, my dear children. But symbolically we write 1 minus. 1 minus denotes left hand limit of f of x at x is equal to 1. Okay, my dear children. Right. As x tends to 1, I told you previously after deciding the function, here no need to write 1 minus. We have decided left hand side function is f of x is equal to a plus bx. So a plus bx. Understood this step, my dear children? Directly we have to consider this function only, not this function. Understood this step, my dear children? Right. Now we substitute. We use a substitution method. So a plus b into 1. Here I substituted x is equal to 1 in this function because x is approaching to 1. That is why we are substituting x is equal to 1 in this function. Then we got this step. Okay, my children, understood this step? Right. That is equal to a plus, what will you get? B into 1? B only. So this is the left hand limit of f of x. Understood this step, my children? Understood this part? Similarly, we find right hand limit of f of x as x tends to 1 plus limit of f of x is equal to. Okay, my children, remember this symbolic form of right hand limit of f of x as x is approaching to 1 from right. Okay, my children, remember these notations. Then as x tends to 1, limit, which function should be considered? This function or this function? Yes, this function, because x is approaching to right side 1 from right side means greater than 1, x greater than 1. That means b minus ax. B minus ax. We have decided, we have finalized the given function in that interval. So this function only. So we have to write this function only, not this function. Understood this point, my children? Right. After that, we have to find the limit of this function as x is approaching to 1 by using the substitution method. So we use the substitution method. B minus a into 1 Understood this step, my children? I substituted x is equal to 1 in this function because x is approaching to 1. So first and foremost method is substitution method. So we used substitution method. Then we got this step. Understood this step, my children? Right. That is equal to b minus a into 1 a. So this is the right hand limit. This is the left hand limit. This is the right hand limit. Understood this part, my children? Right. Now we substitute these two values in the equation 1. What is this equation 1? As x tends to 1 minus limit of f of x is equal to as x tends to 1 plus limit of f of x is equal to f of 1. F of 1 means this only. At x is equal to 1. Put x is equal to 1, what will you get? F of 1. That is equal to 4. So it is a 4. Okay, my children? Right. We substitute. Let us substitute as x tends to 1 minus limit of f of x is equal to a plus b, comma, as x tends to 1 plus limit of f of x is equal to b minus a, in the equation 1. In this equation we are substituting these two values. Then we get, what will you get first here? What is the value of this limit? A plus b. A plus b is equal to, this limit is a b minus a. B minus a is equal to f of 1. F of 1 is equal to 4. Understood this step, my children? First I wrote left hand limit, that is a plus b is equal to second term. This is the right hand limit. What is the right hand limit? B minus a. I wrote it in the middle. Okay, my children. After that is equal to sign f of 1. F of 1 means 4. Okay, my children. Understood? In this equation 1 we have substituted the three values. Then we got this step. Okay, my children. Understood? Right. So from this equation we can write a plus b is equal to 4. First term and last term. I am taking the first term and last term. This implies a plus b is equal to 4. Let us consider this is equation 2. Next, b minus a is equal to 4. B minus a is equal to 4. Or minus a plus b. Minus a plus b is equal to 4. Can we write this expression like this or not, my children? Just I rearranged the terms according to our convenience. Can we write this expression like this or not, my children? Once think about that one. Yes, we can write like this. This expression can be written minus a plus b is equal to 4. We got a second next equation. So let us assume that this is equation 3. We got here two equations in a and b in two variables. Two unknown quantities a and b. This is one equation and this is another equation. You have solved linear equations in two variables in 10th class, my children. Just to recall that concept, recall that previous knowledge. We have to use that previous knowledge. You have to use that concept to solve these two equations. Okay, my children? Right. I am adding these two equations. Then we get plus a minus a gets cancelled. What we get? 2b is equal to 4 plus 4. What will get? 8. Now we got a simple equation. Now let us simplify this simple equation by transposing 2 RHS. Then we get 3 is equal to 8 by 2. It becomes by 2. Okay, my children? Right. 2 once, 2 4 times. This implies b is equal to 4. So this is a value of b. Now let us substitute b is equal to 4 either in the equation 2 or in the equation 3. We get a value. We get a value of a. So substitute Here I am substituting b value, b is equal 4 in this equation. Okay, my children. So a plus b is equal to 4. So this is second equation. So in the place of b I am writing 4. Understood this step, my children? Right. So here 4 gets cancelled. Then what you will get? A is equal to 0. So these are the possible values of a and b. So that as x tends to 1, limit of f of x is equal to f of 1. Okay, my children, understood? Some students requested me to explain some more sums, some more problems in this exercise, sir. We were not able to understand the problems. That is why I am explaining some more problems in this exercise. Okay, my children. But you try the remaining sums. Okay, my children. You have to try yourself. First, do the effort. Do the effort from your end. If you have any doubts at any step, then I will help you. I will explain you. But there is no time. Time limit is there. It is not possible to explain each and every sum in the exercise. I will explain the concepts and I will explain some questions. Not every question in the exercise. Okay, my children. I hope you understand. You understand the problem. Okay, my children. Don't ask me next time. Explain every question in the exercise. I have no problem. I have no objection. I don't have any objection. But time limit is there. Please understand, my dear children, this problem. Okay, my dear children. Right. Complete the syllabus also as well. Within the short span of time, we have to complete the syllabus also. Okay, my dear children. If you don't want to complete the syllabus, if you don't want to complete the syllabus, then I will explain each and every question very slowly. I don't have any objection. Okay, my dear children. Right. First you try yourself. Either it is right or wrong. Whether you are getting right answer or wrong answer. First try yourself. Then come to me. Sir, we are not getting the correct answer, sir. Where we have done mistake. Then I will explain. I will rectify your mistakes. Okay, my children. Without doing effort. Without doing effort from your end, I cannot explain each and every question. Time limit is there. Please understand this problem, my dear children. Okay, right. Now come to the question number 29. Let a1, a2, a3 and so on, an be fixed real numbers. And define a function f of x is equal to x minus a1 into x minus a2 into x minus a3 and so on into x minus an. A function f of x is defined like this. And here what is given? a1, a2, a3, these are all some fixed real numbers. Now what is as extends to a1 limit of f of x? Then we have to find limit of f of x as x is approaching to a1. This is the first part. For some a is not equal to a1, a2 and so on, an, compute as extends to a limit of f of x. This is the second part of the question. Okay, my children. Right. Now first write the given data here. Given f of x is equal to x minus a1 into x minus a2 and so on into x minus an, where a1, a2, a3 and so on, an, these are all fixed real numbers. They are fixed real numbers. Now come to the first part. As extends to a1, limit of f of x. Okay, my children. As extends to a1, limit of f of x as extends to a1, limit of, what is f of x here? This is the given f of x. Let us write this given function here, x minus a1 into x minus a2 and so on into x minus an. Understood this step, my children? I substituted the given function f of x here. Okay, my children. Now, we will find the limit of this function as x is approaching to a1. What is the first and foremost method? Do you remember that method, my children? Yes, substitution method. Let us substitute x is equal to a1 in this function. Okay, my children? Right. So, a1 minus a1 into a1 minus a2 and so on, a1 minus an. In this function, I substituted x is equal to a1 because x is approaching to a1. Then we get to this step. Understood this step, my children? Right. That is equal to, in this first two brackets, what will you get? a1 minus a1? 0. So 0 into a1 minus a2 and so on into a1 minus an. Okay, my children, understood this step? So 0 into any number, what will you get? These are all real numbers given already. They are fixed real numbers. These are all fixed real numbers. a1 minus a2 also we get some fixed real numbers and so on. These are all some fixed real number. 0 into any number, what will you get? 0. So this is the limit of f of x as extends to a1. Understood this first part of the question, my children? Right. Similarly, let us find the second part. Let us compute as extends to a. As extends to a, limit f of x is equal to, as extends to a, limit x minus a1 into x minus a2 into x minus a3 and so on, x minus an. I wrote here the given function f of x here. We have to find the limit of this function as x is approaching to a. What is the method we have to use? First and foremost method, yes, substitution method. Let us substitute a minus a1 into a minus a2 into a minus a3 and so on into a minus an. Okay, my children, understood this step? I substituted x is equal to a because x is approaching to a. I substituted x is equal to a in this function, then we get to this step. Okay, my children, understood this step? That's all. Here no need to simplify these numbers. We can't simplify these numbers. This is nothing but the limit of f of x as x is approaching to a. Understood, my children? Right. Now come to the question number 30. Okay, my children, question number 30. If f of x is equal to mod x plus 1 when x is less than 0, f of x is equal to 0 when x is equal to 0, f of x is equal to mod x minus 1 when x is greater than 0. Understood this function, my children? What is this function called? Yes, a piecewise defined function. Remember that mathematical terminology, my children. Right. For what value or values of a does as extends to a limit of f of x exist? Okay, my children. Right. Come to the solution part. Given f of x is equal to, I wrote the given function here. What should we do first? We have to rewrite the given function because the given function f of x is defined absolute value function. So we have to rewrite. We know mod x is equal to, we know that mod x is equal to x when x is greater than 0, mod x is equal to minus x when x is less than 0. This is the definition of absolute value function or modulus function. Okay, my children, we have to use this definition, we have to use this concept, we have to use this knowledge to rewrite this given function. Okay, my children, right? Therefore, f of x is equal to, here see the variable x, x is less than 0. When x is less than 0, mod x value is equal to minus x. So in the place of modulus of x, we have to write minus x plus 1. We write the remaining terms as it is. Just we are changing, we are transforming modulus of x into this form. Understood this point, my children? Right. When x is less than 0. Okay, my children, right? F of x is equal to 0 when x is equal to 0. Okay, my children. Similarly, come to this third step. Modulus of x is there when x is greater than 0. See here, when x is greater than 0, what is the value of modulus of x? X only. So in the place of modulus of x, we have to write x only. X minus 1. X, we write the remaining terms as it is, x minus 1 when x is greater than 0. We rewrote the given function f of x, okay, my children, by removing the modulus symbol. Understood this step, my children? Right. Now, let us represent, this is a piecewise defined function. This is one interval, this is another interval. How do you denote this inequality in the interval form? My teacher, do you remember? Minus infinity, comma 0. This inequality can be written as x belongs to minus infinity, comma 0. Here we can write x belongs to 0, comma infinity. This inequality can be written as in the form of interval like this. So f of x is defined in three different ways in different intervals. Okay, my children. Then what do you say here? F of x, a piecewise defined function. Here I am not writing that sentence because I have written two, three sums for the two, three sums I have already written that mathematical terminology. So I am not writing. In the examination also, you no need to write that sentence, piecewise defined function, but just you learn that point. Okay, my children, right? Now I am representing this function on the number line, on this number line. So at x is equal to 0, f of x value is 0. X less than 0, how the function is defined? F of x is equal to minus x plus 1. Okay, my children. On right hand side, x greater than 0 means right hand side of 0. F of x is defined as x minus 1. You have to consider this function. Understood this point, my children? Right. So with the help of this data, let us find the left hand limit and the right hand limit of the given function. Okay, my children, left hand limit and right hand limit. These are the short forms of the words left hand limit, right hand limit. For the previous questions, I wrote it clearly. HL stands for left hand limit, or HL stands for right hand limit. Okay, my children. So for this function, let us find left hand limit and right hand limit at x is equal to 0. How do you denote symbolically? How do you write? As x tends to 0 minus limit f of x. At this particular point only we are finding left hand limit and right hand limit. Symbolically we write it. Okay, my children, you have to learn this symbolic form of left hand limit as well right hand limit also. Okay, my children, right? So as x tends to 0, limit we have decided, we have finalized in the left hand side. What is f of x here? Minus x plus 1. Okay, my children, minus x plus 1. So here I am not writing as x tends to 0 minus. This is enough. As x tends to 0, it is enough. Okay, my children, remember these points. Remember these steps, my children. Right. Now we have to find the limit of this function as x tends to 0 by substitution method. Okay, my children, that is equal to minus 0 plus 1. Here I am substituting x is equal to 0 because x is approaching to 0. So in this function I am substituting x is equal to 0. Then we get this step minus 0 plus 1. Understood this step, my children? Right. Let us simplify these two numbers. What will you get? 0 minus 0 plus 1, 1. So this is the left hand limit. Similarly, let us find the right hand limit. So how do you write symbolically? As x tends to 0 plus limit to f of x. Okay, my children, you have to learn this symbolic form of a right hand limit as x tends to 0 plus limit of f of x is equal to, as x tends to 0, limit of, have you finalized the given function as x greater than 0? Yes, we have finalized. This is f of x. So we should write this function, not this function. So x minus 1. Understood this step, my children? We should not take f of x this one. You have to take this one only because x is greater than 0. X is approaching to 0 plus means x is greater than 0. When x is greater than 0, f of x is defined like this, x minus 1. That is why we have to take this function only. Understood this step, my children? Right. Now we have to find the limit of this function as x is approaching to 0. By which method? Yes, substitution method. That is equal to 0 minus 1. I substituted x is equal to 0 in this function because x is approaching to 0. Then we get this step. Understood this step, my children? Right. Now let us simplify these two numbers. What will you get here? Minus 1. 0 minus 1, minus 1. If you find here left hand limit is 1, right hand limit is minus 1. Are these two numbers equal? No. So therefore here LHL is not equal to RHL. Left hand limit is not equal to right hand limit. So what will you say here about this function? As x tends to 1, so as x tends to 0, as x tends to 0, limit of f of x does not exist. Therefore, as x tends to 0, limit of f of x does not exist. So at this particular point, limit of this function does not exist. So what can you say about a? What is asked the question here? For what value of a or for what values of a limit x tends to a, as x tends to a, limit of f of x exist. So for a not equal to 0, for a not equal to 0, because for a is equal to 0, limit does not exist. Okay, but for a is not equal to 0, as x tends to a, limit of f of x exist, except at this value limit of this function does not exist. Except this value at every real number except this 0, the limit of this function exists. Understood this point, my children? Right. Now will you try the remaining two questions, my children? There are only two more questions, 31 and 32 in this exercise. Will you try yourself, my children, by using this knowledge, by using this concept? First try yourself, my children. After that come to me. Without doing your effort, you simply bringing a question to me and explains our full question. That is not a correct method. That is not correct method. First you try it and show me. How did you complete that question? How did you solve the question. Let me know it where you have done mistakes. Okay, my children, let me know where you have done the mistakes. Then I will rectify that mistakes and I will help you in all ways. Okay, my children. Understood, my dear children? Will you try the remaining two sums yourself, my dear children? Right. In the next class, I will explain 13.2 exercise 13.2 sums. In the meantime, please learn what is the definition of different derivative. Okay, my dear children. First principle, derivative. Definition of derivative from the first principle. You have to learn that first point. After that, learn the standard derivatives. I have given 11 standard derivatives formulae. Learn them well, my dear children. Okay, my dear children? Right.